In this section, we review the algebra and starting out by reviewing some terminologies and some common simplification of expression we will use in calculus and some common equation that needed to convert into first and second degree equations. And finally, the geometry of absolute value equation, the simple ones. So, factorings, and one of the factorings formula we use are these two quite often. And for examples, and I can change the expression 6x, these expressions in the factoring formulas, then I change to this. This is called a factor form, and this is called an expander form. The things about factoring that we are going to use is the following fact that we're going to use to check for the sign of output. So here's a problem. For example, here's a polynomial in the expander form. And the question is, I want to plug in 2.03 for x. Will the outcome be positive or negative? Did not ask for what the outcome is, just for as for the sign. So imagine plugging in will be very difficult to do, but if I were to factor it, then I plug in 2.03 individually into each parentheses, figuring out the sign of each parentheses. The only minus sign is the last one over here. Hence, the product is negative, so the output is negative. This is not faster than actually computing the output. This works for fractional factor form too. So fraction also has expander form, factor form. One of the things we use for factor forms that again cancel and simplify, quote unquote. Okay. Expressions. One of the things, a lot of things about fractional expressions that we will use the least common denominator. And one of the things we use quite often is use the least common denominator to multiply somehow to the expressions to clean it up. In this case, the least common multiple is 48. So multiply by 48 over 48, which is 1. But the actual multiplications, I only use the from one to distribute it and then simplify the product. Then I get these add up to be 31, and therefore is the answer. Okay, it's a shorter book accounting method. I can do the same things with expressions. First, find out what's the LCD. You factor these two expressions, and the LCD will be these with that because y minus 1 only need one of them. And then here's a little variations of the problem. I take this LCD multiply to this problem, and then it simplified down to this minus that after cancellation. Then I calculate the result, which is the numerators sits over the LCD over here. So that's how we put them together. Here is another way to use the LCD, and here this problem want to simplify it and actually cancel the H. So what I do is multiply the top and bottom by the LCD of the fractions in the problem. And then I leave the bottom one alone. Don't do anything with it. Then distribute the top one and then clean up the mess. And the 2H cancels out and leave you 1, and that's the answers. And here is another one, similar problem, which we use the conjugate formula, the square difference formula. This we use to change the expression into another one where the denominator, where the square root is put underneath instead of on the top. We'll call this rationalize the top. So what I do is multiply the both up and down by the conjugates. Then the square root disappear from the top, and it shows up on the bottoms. And again, in this case, H and H cancels out. Okay, and we will use this later on quite often. Now we come to equations. So I assume you know how to solve first degree equation and second degree equation by factorings or use quadratic formula. Now let's look at some equations that we are the form of equation which basically any other form of equations, we have to transform that into first and second degree if we want to solve it by hand. In these problems, so one type of problem is this, which will have to square both sides. And notice I have to square the left-hand side by its entirety. So the result will be this. And after cleaning up, I get another square root equation, which I have to square again. Then I obtain this second degree equations. Okay, so this is how we change from original things into equation to a second degree equation in this case, and then solve it and check the answers. Similarly for fractional equations, this one again we use LCD to transform the problem into a second degree equations. Multiply both sides by the LCD. After canceling each term, multiplication of each term, I get this equation, and this is a second degree equation, and I will leave it up for you to solve. Okay. How do I transform this type of equation? Well, for power equations, okay, we will raise both sides to the reciprocal. So in this case, raise both sides to the -3 power because the exponent multiply. So I'll get x to the first power on the left, and the answer on the right-hand side, which is 164. And here's another examples using that. Okay. Then finally, we get to the absolute value. The absolute value between x and y, which is the same absolute value of y minus x, is the distance between x and y. So x minus 7 equal to 12 means I'm looking for x that's 12 units from 7. And that easily you can get the answer. It's 19 to the right and -5 to the left. Okay, so this distance notions for absolute value is very important. That's it. Bye-bye.